Hi everyone, I want to take this chance to welcome you again to our study on metals. I want us to proceed with the study of metals. In our previous lesson, we did the introduction of chemistry of metals. We looked at three major aspects. Number one, I gave the general importance of metals, using typical examples. And again, I said that metals exist naturally, underground. And I said that they exist in either uncombined forms or combined forms. I said the combined forms, we can have alloys, we can have oxides, sulfides, carbonates, sulfates, and even chlorides. I listed 6 metals. I gave the ores or the compounds in which they exist. And I said these compounds in which metals exist are known as ores. I said we have got 2 major types of ores. We have got the major ore and the minor ore, whereby a major ore is an ore which contains that particular metal but in abundance. And the minor ore is an ore which contains the same metal but in small amounts or quantities. Now, I listed all the metals under study, that is 6 of them: sodium, aluminium, lead, copper, iron, and zinc. Today I want us to look at a typical metal. How can we extract it from its ore? And the metal of interest today is none other than lead. How can we extract lead from its ore? So I will remind you on the major ores as well as the minor ores of lead. Now, the major ore of lead is known as galena. Galena is lead sulfide. The minor ores, we have angelicite. Angelicite, we have lead sulfate. Another one we have cellulite, known as lead carbonate. Now these ones are the major ore. The major impurity in these ores, we have silica. Silica is the major impurity in these ores. Now, there must be a mechanism we will employ to remove this impurity to enable us to obtain a pure metal of lead. Now, the first step, the ore is mined from the ground. Once the ore has been mined from the ground, the ore is crushed into fine powder. Why is the ore crushed into fine powder? The ore is crushed into fine powder to increase the surface area of contact between the ore and the reducing agents, which will reduce the ore to a metal. More specifically, galena being the major ore, or lead sulfide being the major ore, because this is the formula, lead sulfide. Now, lead sulfide is the major ore. Now, but before the ore is subjected to reduction process, the ore has to pass through 2 major stages. Number one, the ore has to be concentrated by a process known as froth flotation. I said in our previous lesson that this is the process of purifying the ore through concentration, whereby I said we add a frothing agents, and the frothing agents, they separate and remove the impurities, allowing them to sink and leaving the ore floating, and the floating ore is given a name, but a froth. The name of the floating ore is not the froth. Now the froth is passed into the roaster, and within the roaster, what we have, air is added or passed. And remember, the active part of air which would react with the ore is known as oxygen. Now, in the roaster, the ore is roasted or is reacted with oxygen. Now, the ore, for example, lead sulfide is reacted to form lead oxide and sulfur 4 oxide. We can balance it by having 3 here, then we have 2, then we have 2, and then we have 2. A solid, a gas, a solid, and a gas. Now, in the roaster, the ore is roasted to form lead oxide and sulfur oxide. Sulfur 4 oxide is an acidic gas, and therefore it cannot be and it should not be allowed to the atmosphere, because it will cause pollution to the environment. Why? Because it will react with moisture or rainwater to form acidic rain. The mixture of sulfuric acid, or you can call it sulfuric 6 acid and sulfuric 3 acid. Sulfuric 6 acid and 3 acid would have adverse effects. Number 1, causing leaching of nutrients, depriving the soil from nutrients, reducing soil facilities. Again, due to the acidic nature of this acidic water, it may interfere or decolorize. As we know the properties of sulfurous acid, it is a bleaching agent. It may bleach the green coloring matter of a plant, the chlorophyll. And when this is done, to mean photosynthesis will not take place, and therefore there will be stunted growth of the plant. Again, this acid can also cause what is called defoliation. It may interfere with the foliage, the leaves of the plant, generally by killing the plant, since remember, cells within the plants are very crucial for the growth of the plant. Again, this acidic rain can also cause corrosion to iron sheets, reducing its quality. Again, these acidic compounds can also cause problems to respiratory system. Now, these compounds, acidic compounds, or acidic rain can also interfere with aquatic life. Now, and that is why sulfur 4 cannot be released to the atmosphere once it has been formed. It is therefore used in a nearby sulfuric acid plant for the manufacture of sulfuric acid, as we know in Form 3, and a sulfur is compound, sulfur 4 oxide gas is used in the manufacture of sulfuric acid in contact process. Another alternative is to use sulfur 4 oxide in scrubbing process. Now, scrubbing process is whereby sulfur 4 oxide is reacted with calcium hydroxide. Now, calcium hydroxide is reacted with sulfur 4 oxide to form calcium sulfide and water, and these are harmless to the environment. Now we have obtained lead oxide. Now lead oxide is passed into the second chamber, reduction chamber. Now in the second chamber, there are two substances added. Number 1, we have coke. Number 2, we have limestone. Now coke is just carbon and limestone is calcium carbonate. Why do we add calcium carbonate and coke? Calcium carbonate will be decomposed to form calcium oxide. So calcium carbonate is decomposed through heating to form calcium oxide and carbon dioxide gas. Now calcium oxide is reacted with a major impurity, silica, to form calcium silicate. So we have calcium, silica, and 3 oxygen atoms. So this one is tapped off and removed from the system. It's tapped off as a slag. Calcium silicate is removed from the system because it will make the ore to be impure. Carbon dioxide is reduced by coke, which is carbon, to form carbon 2. Carbon 2 is a suitable reducing agent because it creates a large surface area in contact with the oxide to be reduced. Now, this carbon 2 oxide is used therefore to reduce lead oxide to lead metal. And carbon dioxide gas is produced. And carbon dioxide gas is produced. So carbon dioxide gas is also produced. And remember, carbon dioxide gas is also acidic gas and therefore should be used in scrubbing process whereby it reacts with calcium hydroxide to form calcium carbonate. Now, this metal is not pure because there are some impurities which were not removed through froth flotation and therefore the metal is impure. And remember, before I proceed, apart from carbon dioxide, the remaining carbon can also do the reduction process of reducing the oxide of lead to form lead metal and carbon dioxide. So these lead metals are not pure. A question: how do we obtain the pure lead metals which has been formed by reduction process? We obtain the pure lead by using 2 methods. Number 1, we can use electrolysis. Number 2, we can use blowing of hot air blast. Now, blowing of hot air blast would oxidize any impurity, and when this is done, all impurities, or nearly 85% of the impurities are removed. But this method is not efficient because some impurities cannot be oxidized. The best method to produce a pure lead is by electrolysis, whereby the impure lead is electrolyzed in electrolytic cell, as shown below, having the anode being the impure lead and the cathode being the pure lead. And then you must have DC direct current. And then you dip the two electrodes into the solution of lead. For example, lead nitrate. Now, why are we doing this? Having lead or impure lead at the anode and pure one at the cathode is key, because the impure lead will dissolve into the solution, producing lead ions. Now at the anode, we have the impure lead dissolving into its solution, producing lead ions and two electrons. Now the ions being positive migrate to the cathode, where at the cathode lead ions are reduced to form pure lead metal. Now, as the lead ions migrate towards the cathode, they leave behind the impurities. Now, in this case, these impurities are known as sludge. Now, the reason as per why the impure lead is meant to be at the anode, it is because to allow it to dissolve into its solution, producing the ions of lead, they migrate to the cathode, leaving behind the impurities. Now the lead deposit formed at the cathode is now pure and can be removed or obtained or collected and used in various applications. Now, we can apply lead in so many ways. By the way, some industries which are responsible in the manufacture of lead acid accumulators are using lead to make the acid accumulators. So the lead is acting as electron. And again, for some petrol engines, a compound known as tetraethyl lead is used as an antidote. So we have tetraethyl lead is used as antidote in petrol engine. Now this is the general process of extracting lead from its ore. Number one, you must know the major ore. We have galena, lead sulfide. Number two, you must know the minor ores. We have agaricite and cerussite. Number three, you must know the impurities. We have silica. And then number four, you must know that we have rust to convert into oxide first. Number five, you now go to removal of impurities by adding calcium carbonate, which decomposes to give us calcium oxide that removes silica in the form of calcium silicate, which is actually a slag. And again, we have now the reduction process whereby carbon 4 oxide produced is reduced to carbon 2. Carbon 2 reduces lead oxide to form lead. This lead being impure, it has to pass through two processes. We can use this or this. You electrolyze it, or you can blow air to oxidize the impurities. Now, I've shown you how electrolysis is done. Thank you so much. God bless you. Welcome.